Hey, Madison here. In our last episode, we spoke with Sarah Doss, a Scientist Emeritus at Woods Hole Oceanographic Institution, about how climate change is affecting the big polar ice sheets of Antarctica and Greenland, where she's been traveling for her research since the 90s. We had so many questions for Dr. Doss about her work at the poles, and we couldn't resist sharing a little more of our conversation with you. So on this special episode of Ask MIT Climate, she's back to give us a behind-the-scenes look at the life of a polar glaciologist. I'll let Dr. Doss take it from here.
I grew up as an outdoorsy kid in a family where we were always going out and about. I grew up in Pennsylvania, so far away from any glaciers or really mountains to speak of. But we had snow, which was fun. I always enjoyed snow. I also have always been drawn to the natural world and trying to, just ask questions and understand how the world works, how nature works, how things sort of, come together, fall apart. As I grew up, I definitely developed an adventurous streak as well. And so all those things combined really led me to want to be in a field where I could spend a lot of time outside. And the idea that I might be able to do that and combine that with a career was very appealing. I've been actually working on the polar ice sheets for over 30 years. In the sort of mid-career, I had a couple years where I was working at both poles. So I would be in Greenland maybe for a month or two in the summer. I'd come back. I'd kind of decompress from that, start digging into that data, and then a few months later have to be preparing all my equipment and shipping things down, going to Antarctica for a couple months. Most of the U.S. research that happens in Antarctica goes through McMurdo Station. And if you were to look at a map or a globe, and you found New Zealand in the southern hemisphere, you draw a line sort of south from there, and you'll get to this part of West Antarctica where McMurdo Station is. I've only worked through McMurdo in my career. So we've always traveled through New Zealand, where the U.S. has an Antarctic center. And they would help you get all set up with your gear, your cold weather clothing. You do a little bit of training, and you would wait for a good weather window to fly there. And the weather was really important because it's still really far from New Zealand to McMurdo Station. And one of the experiences I really remember the most about those first few trips is what they call these boomerang flights. So you would be waiting and waiting in New Zealand, and you would be called maybe the night before or early in the morning. Okay, the weather looks good. We're going to go. Get all your gear packed up and leave the hotel, and you'd go to the airport. And you'd wait around some more. And finally, you'd get on these big military aircraft, you get strapped in, and you'd start flying. So even on a go day, you would get on knowing there was a chance that you would get halfway there and have to turn around and come back. They would have to make a determination about halfway through. If we go past this point, we no longer have enough fuel to get back. So we have to keep going. But if it's stormy or, the stakes are pretty high, right? So quite a few of my flights every year would turn into these boomerangs. And then you'd end up on this plane for like 12 hours and end up right back where you started. So we'd get to McMurdo, and we would do safety training, depending on where we were going. If it was your first time down, everyone had to do something called Happy Camper School, which was really to make sure that you could survive if you were lost or in a whiteout or your plane broke down. And so they would take everybody, no matter what your job was there, and you'd go through this overnight training, or you would learn how to set up a tent, light a stove, find your way in a whiteout. You would put like a bucket over your head, and you'd have to figure out how to get back safely. And then you would spend the night out there. Some people would build snow caves and igloos and sleep right out there in the snow. So all that takes time, but it's part of the adventure. It really, I've never been, into outer space, but there's really, I always come back to that when I try to describe what going to Antarctica is like. It really feels like you're on another planet. It's sort of monochromatic in a way, but as you spend time there, your senses are heightened in some ways when you don't have like a whole jungle of colors and noises around. So you start to fill in, right? The blue sky is bluer than you've ever seen, right? Or you'll see birds go by, have a hint of, some color on their beak, and something like that just really stands out to you. Once you get into the middle of the ice sheet, it reminds me in a way of being out at sea. Once you're far enough from land that you can't see anything else. It's quiet in a way, but that just means other sounds are accentuated, right? So the creaking of the snow when snow is very cold, it has that sort of creaking sound when you walk across it. Or if, ice is cracking or breaking up in the distance, those things just really stand out and are very stark. And then the surface is changing every day. So it's white, right? But it's not boring white. It's not like a piece of paper. The surface really responds to what's happening in the atmosphere and in the weather that day. So maybe you'll have a really big storm that'll come through, a blizzard. And when it's really blowing snow or snowing hard, there's white all around you. It's like being in a snow globe. You have no sense of orientation or distance or anything like that. It's very disorienting. But once that storm has passed, now all of a sudden the surface is completely transformed with, new forms of, snowdrifts or piles, and the sun will come out and it will hit the crystals, these fresh snow crystals, and you'll just start to see like rainbows of colors on the ground. You can have diamond dust, which is when it's so cold that it's not snowing, but there's moisture being kind of sucked right out of the dry atmosphere. And you just have, you look up in the blue sky and you just have little bits of, diamond dust is the best way to describe it, just falling all around you. It's really incredible. So I've asked a lot of different questions scientifically about ice over the course of my career. Some of the big themes that they fit into, one has to do with using ice cores as kind of a time machine, right? This field of paleoclimate where we use natural archives that are on Earth to extract records that can help tell us about how Earth and climate were behaving in the past. And ice sheets preserve some of the best high-resolution records of how Earth's climate has changed. As you're sort of drilling down from the surface down through the thickness of the ice, you have year after year after year of past snowfall layers that are preserved and compressed. And so, on an ice cap or an ice sheet that may be a few hundred meters thick, you could have ice that's thousands of years old at the bottom and, recent at the top. So a project that I led about a decade ago was in West Greenland. And it actually originated because I had been traveling in and out of this one town, Ilulissat, for a long time. We would stay in these hotels where we'd look out over the mountains to the north and the west, where there were islands and peninsulas that had these ice caps. So ice caps are like, tiny little ice sheets up on top of mountains. They're not connected to the Greenland ice sheet, but they're part of the larger Greenland ice system. And so we conceived of a project where we would go to these smaller ice caps on islands and peninsulas that were in these coastal environments and see what the records looked like and how they might help us understand what's happening in coastal regions as opposed to, say, the interior of Greenland. The first year we went and we collected just shallow ice cores from many different locations, and we sort of better understood how do we work in these areas? What kind of equipment do we need? How do we fly there? How do we learn from the pilots what they're comfortable with? So we did all these sites to figure out where we wanted to go do our deep coring, brought everything back, and were able to narrow down a few target locations for the following year when we put a team together again and flew out. And now we have a whole different setup because now we're trying to go down 100 or more meters down into the ice itself. So we have a whole mechanical drill, and we would ship everything up and would have a generator and a tent and our fuel and our food and our camp. And we would be set there for, a week or so. And we would start drilling down and we would bring up cylinder after cylinder. And as the pieces came out, you would do some initial measurements on them right in the field. So their length and their density and anything of note, and pack them up carefully in these big boxes. And then you would just keep going. And inevitably you would hit some, snafu. So something would break or something would freeze. But that's sort of, par for the course, I guess, in that environment. So we managed to get through all of our sites, not without many incidents, but and then we'd pack all these boxes up, and we were working out of 3 different towns. And, like in one town, we used the airport freezer where they would put their frozen food when it would come in, right? And they said, yeah, you can put your ice in here. Because once you've gotten it out of the ground, you got to get it all the way back to the lab, and you can't let it melt, right? That would be a disaster. So a big challenge every year was also, how do you actually get that ice back from Greenland or Antarctica? And that's a whole story in and of itself, because If you imagine a big airplane full of boxes of ice, you wouldn't want the interior of that plane to be too warm. So they call those ice core flights cold decks. And if you're on a cold deck, you're freezing because they don't heat the plane. So nobody ever wants to travel on the cold decks, including the scientists who collected the ice. A question that people often are interested in, right, is like, you've been there so many times over so many decades. Have you seen changes? Most of the changes that I've been able to see over my sort of repeated visits has been in Greenland. So I've been working in the same part of West Greenland for a really long time. And while many things have stayed the same, where you really notice differences is around the edge of the ice. You're flying up and you're going over these fjords, and then you're getting right to the edge of the glacier. You start to sort of pick up on things like, oh, the front of that glacier where it's meeting the sea is further back than it used to be. Or there's a big change in how many icebergs are out in the bay or are coming off the front of the glacier. And because the glaciers there are thinning and retreating, you start to uncover, land that's now visible that used to be covered by ice. So those were all changes we were able to see firsthand. Another thing that is definitely a visible change, but it's a little more nuanced, right, has to do with the timing of the melt season. So a lot of the work we do in Greenland, we want to be there in the summer or the spring as temperatures are starting to rise and the surface of the ice is starting to melt. And we've definitely noticed over the course of our research that the beginning of that melt season has been creeping up forward and forward. And you can measure that just with, looking at temperature records or climate data or things, but you really feel it when you're, boots on the ground and you say, oh, we're here this year and it's really slushy. And, maybe 10 years ago it would have been frozen up. I think it's incredible that we are here, alive, all of us together on this planet at a time when there are these polar ice sheets. There have been plenty of times in Earth's history with no ice whatsoever. And I just invite everyone for a moment to, just sort of embrace the wonder, the amazing fact that we have these enormous ice sheets on this planet, that they still exist. That said, they're changing very quickly. This is a warning that we can all wake up to and say, look, this is real. We understand it. We can measure it. And we have time still to make changes and to slow down melting ice, but also to slow down all sorts of other dramatic changes, many of which are going to be challenging for people and for ecosystems. If you think about projections that people were making decades ago about sort of the worst scenarios in terms of global warming and consequences, we've already bent that curve downwards. And could we be doing better? Could things be going faster? Could we be working more harmoniously? Of course. But I think it is important to maintain that sense of optimism and hope, and that collective action will really help us get there.
Ask MIT Climate is the climate change podcast of the Massachusetts Institute of Technology. Aaron Krol is our executive producer. David Lishansky is our sound editor and producer. The music is by Blue Dot Sessions. And I'm your host and associate producer, Madison Goldberg. Many thanks to Dr. Sarah Doss for speaking with us about her work, and to you for listening. For more episodes of the show, including our other one with Dr. Doss, check out climate.mit.edu.